representing NAE Group 42 from the University of Houston's Engineering 1331 course. We created a program that acts as a decision support system for the global issue of access to clean water. A decision support system, also known as DSS, is a software-based information system that processes large amounts of data and outputs it in a user-friendly manner that helps people, businesses, or governmental authorities make better decisions. The human race is reliant on access to clean water. That is why this is such an important topic. An average human can only go 3 to 4 days without drinking water. For countries that have difficulty accessing clean water, people living there may only be able to drink the bare minimum, which could possibly lead to sickness, dehydration, and even fatal conditions. We understand this need, which is why we have our code, grade the countries the user enters, and based on the grade the countries receive, the program will output a text file containing suggested solutions that can help the country find a starting point on where to fix so they can get a better grade in the future. Traditional grading sets a range of scores that relate to different grades, generally ranging A through F. We chose to grade the countries based on a percentile score. The top 20% of the countries receive an A, the top 40% receive a B, and top 60% receive a C. Using percentile grading is more realistic in this case because a country with 90% of the population with access to clean water leaves the other 10% of the population at serious risk.
So here we have a chart that shows the flow of data, specifically GDP and water access through our code. Initially, we start by downloading the data from the World Bank online database and then import it into MATLAB. Next, we normalize the data and then ask the user to input a country name as well as a year between 2001 and 2016. After the user inputs the values, we then go through several data validation checks for both the country name and country year. For the country name, we make it case insensitive and check to see if it exists in the list of countries imported into MATLAB from the dataset. If it fails the validation check, the user then has to re-enter the country name. With the year data validation, we check to see if the year is in the range from 2001 to 2016. If not, the user has to type in a valid year. After completing both data validations, we then extract the GDP and water access data for the given country and year. We then perform another validation check on the extracted data to see if the country has any data in there. If for some year there are missing data values, we then check to see how many there are missing. The user can then choose if they want to update the missing values with the correct values or proceed and ignore them. Next, we plot GDP versus year, water access versus year, and water access versus GDP for the selected country. These three graphs are then all placed into one figure for the user to easily visualize everything. After that, the water access percentage is scored, and a custom-made solution is then exported based off of the score. Lastly, the user is given the choice to choose how they want to export the graph, either as a PDF, TIFF file, JPEG, or PNG. Once they select an option, the program is then completed.
Demonstrating our NAE Project 1D code. If you'd like to follow along, hit pause now and download our file. The first thing our code asks you to do is input a country's name. We will misspell Aruba with 2 R's to test that. Note how it asks us to retype the name. Now we will try just Aruba, spelled properly. Note how it is all lowercase. Our code corrects case sensitivity and fixes it. Next, our year of interest between 2001 and 2016. Let's try 2018 to see if it messes up our code. No, note how it recorrects it and asks you to input a value between 2001 and 2016 again. This time we will respect it and we will try Aruba in the year 2012. Next, note how the menu states that there are 39 invalid values. It asks us if we'd like to input new values. We're going to go ahead and click no because there are 39 full missing values from the years 1960 to 1994 and post-2010. To save time, we will skip over that, but if you have that data, you can correct it. Note how on our GDP graph, here let's go full screen for better viewing. Note how in our GDP graph, 1960 to 1994 is missing, exactly like it stated whenever it said we have 39 missing data points. This graph is basic water access versus years for Aruba. Note how 2012 is highlighted. In our GDP versus years, there is no recorded GDP for the year we selected, so there is no red highlight. At the bottom here, we have a scatter plot of the log of GDP versus basic access to water for the year 2012. Note that this is a log scale because the actual relationship is exponential, but for our purposes, we wanted to apply a linear correlation coefficient to the data, so we turned it into a linear function by logging an exponential function. We will close this figure now. And note how it says what file format do you want data graphs to download as. PDF is preferred because it's MATLAB friendly and you can open it from MATLAB. So we will respect MATLAB's desires and click PDF. If you'd like to run the program again, we will click No. However, I have run this several times prior, so we can take a look at take a look at outputs from previous runs. So we'll take our text out and let's check our report. In the year 2015, log of GDP and basic access to water percentage is moderately correlated with an R-squared value of 0.79. In Aruba in the year 2015, Aruba received a water access score of B. Access to water is a slight issue. Light infrastructure implementation is necessary to improve score. Now let's take a look at their actual PDF, specifically at their basic access to water score in 2015. Now look, they're hovering around 98%, but the way we score is actually by percentile. So in the year 2015, a 97 is only good to get you in the top 40% of countries because that is a B. Top 20% is an A, which is hovering right around 99.3 for the year 2015. So keep that in mind. We will X out. We can check out the United States in the year 2015 and nice GDP graph. And if you take a look, this is the exact same as the previous because it's the same log of GDP versus basic access to water score for 2015. All right, I hope I haven't bored you too much with my presentation. We will move on to a much more fun presentation next. Hey, you!
Who, me?
Want to learn about global access to water issues?
I can't imagine a better way to spend my time.
You want to enter.
I'd love to learn about Colombia, the country my parents were born. I also hold dual citizenship there.
Wow, what great diversity we have here at UH, the second most diverse major public research university in the United States. What year will you select?
I think I'll select 2003. That's when my younger brother was born.
Sounds like a future coup to me.
You betcha. What pretty graphs. What do they mean? I haven't taken statistics yet.
That's all right. It's easy to visualize data when you have nice graphs. Right here, we have a graph representing basic access to water versus years for the beautiful country of Colombia. On the right, we have GDP versus years for Colombia. And on the bottom, we have the log of GDP versus basic access to water for the year 2003. So you can see a correlation between GDP and access to water.
Interesting. What a shame I can't send it to my parents in the file of my choice.
But wait, you can! Click here to export the file of your choice.
Wowee.
What are you cool cats learning about in here?
We're learning
Take it
about...
over, Cat.
Kaylee, come sit down.
Gee, thanks.
We're learning about public access to drinking water around the world.
Wow, that's really interesting.
Yeah. What country would you like to learn about?
I'd like to learn about my home country, Venezuela.
What year would you like to learn about?
Probably 2013.
Interesting.
Let's see. Should I put in new values?
Sure. These are some great values you've picked, Kaylee. All right. So this graph here on the left shows you basic water access versus years for Venezuela. So you guys are doing pretty good. You also have access to this graph here on the right that talks about GDP versus years for Venezuela. And this one on the bottom shows the log by basic access to water for the year 2013.
That's really neat. I'll have to take a picture of this. That's too cool.
Don't worry, you can choose to save the file in whatever format you like.
Any format?
Any format that are PNG, PDF, JPEG, and TIFF.
I'll choose to export it as JPEG.
Wow, data analysis sure is easy when you have great data visualization.
That our program contains is gathering the data and quantifying it. This process is difficult because multiple countries are being measured, containing millions of people. Our program is also only based on a single variant statistic, which is GDP. Although our program provides a solution for each country, it is difficult to provide a specific solution for every country. However, new solutions can be added to our program with ease. Our program is a small-scale DSS, which is able to be upgraded into something much larger. Once upgraded, it can provide multivariate statistics and correlations such as access to water versus infant mortality rate, birth rate, and average life expectancy. Using these correlations, we can decide which variant is the most relatable to water access.